Hey guys, welcome back to another video. My name's Roland and I'm your tutor. Here we will be continuing with a couple more examples, and we'll be dealing with the cos of alpha minus beta. Alright, so there we have it. We've got the alpha in blue and the beta in green. Let's put that in a box. Just take note of the sign, it's negative. And how do we write this? So we say cos of alpha minus beta equals your cos of alpha cos of beta plus your sine of alpha and your sine of beta. There we go. It's easy to see. Can you see you've got your alpha on your cos and on your sine, and you've got your beta on your cos and on your sine. That's something you need to take very good note of, because you'll use this to manipulate equations in trigonometry. Alright, just make note of that. Okay, let's move forward. Let's do a quick problem over here. Well, it's not really a problem, it's more a way of explaining trigonometry. So let's consider the unit circle. The unit circle has a radius of 1. And the points are L, where we have our x value being A and our y value being B, and then we've got the point K with x and y. And these 2 points are shown on the circle. We're going to draw a set of axes with something that looks like a circle. I'm just doing this freehand, so you can't expect a perfect one. There we go, there's our radius from the center out to the edge of the circle. What do we have? We've got 2 equal radii, because the radius is always going to be equal. We then show the green line going from the point down to the x-axis, and we draw ourselves a right-angled triangle. We have an angle, a reflex angle, that goes from the x-axis, we call it alpha, all the way to the second radius. And then we'll use from the x-axis up to the first radius for the angle B. We'll use the line 1 and 1 as a measurement, because that's the length of those lines. And just take note of this. From the center of a circle to the outside or to the circumference of a circle, the lines are always equal. Well, not really to the circumference, I should rather use the correct word, which is the perimeter. The distance is always going to be equal. There we go. Make note of that. Something very simple and very effective when you're calculating trig. Alright, here we have the angle alpha minus beta, because it's not including the yellow beta. We'll do that in purple. We have our point K, which is xy, and we have our other point L, which is AB. There we go, it's in red. Okay. We have another point where the green line meets the x-axis, we're calling that M. And naturally we don't know what the x value is, so we just write an A, but we do know that the y value is 0 because it's on the x-axis. We now draw a point or a line from the origin through to the point M, and we call that distance A. So if you look at it, we've actually got two different measurements for that triangle of origin LM. You've got the length of A, you've got the length of 1 for the hypotenuse, and we do not have the length for the green line. Okay, so we can express the coordinates of L and K in terms of alpha and of beta. How do you think we're going to do that? Okay, so we'll do triangle L origin M, and we'll just say that we're taking the sine of beta, which is opposite over hypotenuse. The opposite length would be B, because that's the y value going up from the x, there we go, up to the point L. And then the hypotenuse is always the longest line, and it's always opposite the 90 degree. And that measurement is 1. So your actual answer would be sine of beta equals B. Therefore, we say that B is equal to sine of beta, or sine of beta equals B. Okay, just in case you're unaware of what's going on, we're deriving the basic equation of cos alpha minus beta. So now, let's do cos beta. We have A over h, which is adjacent over hypotenuse, which is A over 1, as we have it on the diagram above. You therefore can say that we've got A is equal to cos of beta. So therefore, A is equal to cos of beta. Okay. Now, what are we going to do next? We say that L is equal to cos of beta sine of beta, because we say that L is A, comma B, as you can see there at that point. You see where we're going now? We'll do the same for K, which is X and Y. So there we have it. We've got cos of beta for A, and we've got sine of beta for B. So we say that K is equal to cos of alpha and sine of alpha. And there we have it. So there we go, there's K, cos of alpha in the green, and sine of alpha for the Y in the green. So there we go, we've got our big triangle. In case you're wondering, the x and y values are the same as the a and b values of L. Here we go, we've got A is for cos B, just as B is for sine B. And as you can see, if you go from origin up to the blue line along the y-axis, it's the same as having B, it's the same length. And then you can use your horizontal line from where you stop meeting the blue line, going left towards K, you get the same as A. So through a whole series, I guess, of extrapolation, you actually just get cos of A is sine, and sine of A is the points for, are the points for K. There we go. So if you took alpha, you'd say O over H, which would be A over 1. So sine of alpha would be so O over H, which is A over 1. So as we agreed, it's A. And if you did cos, you'd get B over 1. And there we have it. You've got cos of alpha and sine of alpha for the x and the y. So now, what we do to find the distance between the k and the l, you naturally need to do the distance formula. So we need kl squared